He's got yeah. 14.
So let's take a look at this problem. So Mr. and Mrs. Smith have a bakery. Sounds delicious.
Oh, bakery.
The bakery primarily sells 4 items: rolls, bread, cakes, and pies. The amounts of the ingredients that you need to make all that stuff is in the following table. So what they did here is they organized their data into a table for each one that needs eggs, flour, sugar, shortening, whatever. So what they're doing here right away, as you can see in this first figure, this first table, if you will, is they're making a matrix. They're creating a matrix here. They're creating a matrix with tables of values. What they're talking about in the rows deal with the types of food, and the columns deal with the ingredients. So we have food and ingredients. Do you agree? So what I'd like to do here is kind of walk through how you can put these things together. The second one talks about the costs, depending upon whether you went to Sam's Club to buy all your stuff or you went just to Hy-Vee to buy your stuff. Large lot, small lot. If you're going to buy in bulk, you go to a sort of bulk, that kind of thing. So what I want to do here is kind of follow through how they're setting this stuff up in each one of these questions. Now, if you look at question 1, in the space below, write the first table in a matrix and call it matrix A. Now, what I'd like to do is, once again, remember, if you look at the table itself is written up as a what?
4 by 5.
It's written up as a 4 by 5. So what I want to do is create, from this first table, call this matrix A, it's going to be a 4 by 5 matrix. So let's do that. Let's create a 4 by 5. Yep.
Use another sheet of paper.
No, you can just use this. That's why I have it here. That's why I gave you that.
Oh, wow. Easier to do.
All right. Give you guys a second to fill that through. Now, when it comes to those decimal ones, obviously you guys can put decimals or fractions into the matrix. It doesn't matter. It might be a little bit easier, a little less button suppressed if you just use a decimal. It's not a big deal. When we're dealing with this matrix today, for this first example, the next matrix deals with cost. So if we start multiplying these things together, are we going to convert things into fractions if we're dealing with stuff with costs?
Decimal.
Yeah, keep them in decimals because it's going to be relating to a price. Okay. Now do the same thing for matrix B, for that second table. If you look at that second table, what's the dimensions of the table?
5 by 2.
5 by 2.
Very good. 5 rows and 2 columns. So let's just fill that one in as well.
Alright, so we plug that stuff in.
Yeah. Look at the next part. It asks you to multiply matrix A times matrix B. Can you multiply matrix A and matrix B?
Yes.
Yeah.
You can. What will the result matrix wind up as?
4 by 2.
4 by 2. Very good. Remember, when you're multiplying matrices, if matrix A was a 4 by 5, matrix B is a 5 by 2, these two are the same, which means that your result is a 4 by 2. Now, if you had to do this by hand, how many times would you write down the first matrix?
Twice.
Good. Am I going to have to do this by hand?
No.
I could.
No, you couldn't.
Yeah, I could.
Do
Well,
it.
would you do it?
I don't believe it.
Probably
You're right.
not. I'd say I did it by hand, and then I just do it when
Yeah, that'd be
multiplier is turquoise.
Some of these guys look kind of shady.
Okay.
And you didn't have a multiplier.
Oh.
So it's just multiplies.
I usually said it's. And I do something to do.
Alright, here we go. Yeah, I can just feel it quick.
Their hair. Yeah, this is lagging extra hard. This is too big.
Oh my.
All right. When you guys multiply those things out, what did that matrix represent? Price for the ingredient for what? Like a lot.
Necessary
Yeah, that's what we look at. Large lot, small lot. Now here's where it gets interesting about what your data is telling you in a matrix. What happens is, if you go back to the original idea here of a 4x5 times a 5x2, what did those numbers represent? Well, the 4 represented what in the first column? Your goods, right? 5 represented the what? 5 was ingredients. What did the other 5 stand for? Convenient, isn't it? They don't cancel out, but they have to be the same. And then what did the 2 columns stand for? It talked about price. And like you were saying, it's the large lot, small lot. So what happens here is each row, each of those 4 rows is dealing with, let's go, rolls, bread, cake, pie, for the large or the small amount of value. So when you multiply those together, hopefully you got the following. 65, 31. Did you get those values?
No. Yeah. Oh, I got 31.5.
What's that? You never wrote 75 cents? You never wrote it above? Nope. You guys have never written, you guys have never, yeah, it's exactly, it's on price tags. It's $8.79. You don't look at price tags, that's how they write it.
My mom well, there's
I don't if it says 78, I just put like 80.
I don't pay for it, so why should I should really buy it?
39, I run them.
Gonna be happy to worry about
95 is like $100.
Anywho,
like a
now, here's what I'd like you to do. Take a couple of minutes
Oh, you should put it in fractions.
and try to figure out what's going on the next page. Take a few minutes, we'll talk about it here in a second. As we get into the secondary part of these questions, what we've already done here with this third question, we've already defined that. We defined what the 2 dimensions of the original matrices were, 4x5 and the 5x2. Amount, or goods, ingredients, price is how it went in order. The next part is just saying, create a 1x4 matrix. If it's a 1x4 matrix, how many rows does it have?
1.
How many columns?
4.
So is that going horizontal or vertical?
Horizontal.
It's going horizontal.
What about that like small row versus like columns up and down?
What they're asking you to do is you're creating another matrix. It's a 1x4, and it is 1 row, and it represents 20 rolls, 200 bread, 50 cakes, and 60 pi.
Wait, you forgot? Oh, that's.
What's funny is that the person that sat in your exact seat third hour is the first person to laugh at that too. Now, what happens here,
How do you?
Oh.
what this is relating to, think about the three different matrices we have now. Matrix A was a 4x5 that dealt with goods and ingredients. Okay? Matrix B was a 5x2 that dealt with ingredients and price. Matrix C deals with, well, what's going across the road? The goods, and the 4 is the amount. That's what I was looking for. The order. How about this? The order that someone's placing. So what they're asking you to be able to do in the next couple of parts is that you have to create matrices to figure out the cost that it's incurring to create 20 rolls, 200 breads, 50 cakes, 60 pies. You have to be able to adjust your matrices to make that work. Obviously a roll, if you look at your stuff, a roll, according to matrix A, needs 1 egg, 4 cups of flour, 2 sugars, a quarter cup of shortening, and a cup of milk. That is 1 row, and how many columns? 5. So 1 by 5. Now, if I wanted to figure out what my cost will wind up being, I might have to multiply things around a little bit. First of all, I'd have to create how much of each one of these things I need. For example, if I'm going to work with eggs, we all agree that you need to have 5 things to make all these, right? Yes. So if I'm working with eggs, because it says write new matrices to work with the amounts of each individual ingredient. So that means if I'm dealing with eggs, I have a 1 by 4. That is my matrix C. That's my order. And I need to create, well, it's going to be a 4 by 1 or a 1 by 4 to multiply that against. It's going to be a 4 by 1. I have to multiply that against a 4 by 1 to create the total number of eggs that I need. I want to wind up with 1 value. Does that make sense? So here's what we have. If you look at matrix C, it's a 1 by 4. You already know that. It's 20, 200, 50, 60. I need to come up with something. In order to figure out the amount of eggs, if I look at my matrix A, isn't the amount of eggs already written up as a column matrix, as a 4 by 1? When you multiply these together, it'll give you a total amount of eggs, and so on, and so forth. You're doing basically the same thing, keeping this matrix, changing this one for each ingredient. Okay?
That's not 4 or 5
It's,
times.
yeah, basically all you're doing is you're changing the column. So what matrices allow you to do if you're running inventory, it's a way of collecting data and a way of understanding how orders are processed and what you need to fill orders, especially for things like this. Is it the most efficient way of doing business? Not really. I mean, are there other inventory management systems out there that work better? Yeah. But for a regular, simple way of doing things, matrices will work. A lot of people nowadays don't use matrices. They use They use Excel. I'm sure you've heard of that. And Excel is nothing more than, well, it's kind of a giant matrix anyway, when you program it correctly. So what I want you to do tonight with these ones here, I'd like you to try and finish out the questions. There's only this one and another cost one, but I also have a couple more other styles of these built into it. So it's going to wind up like 5 total problems for tonight. What I did was, since these problems are mixed up between the last 3 or 4 sections, is I just made a couple of photocopies of what they look like out of the book, so you don't have to kind of flip around and open up all the different PDF files. I just made a copy of it for you. And I'll tell you which ones of these here specifically I'd like you to look at for tonight.
Are you still my assignment notebook? What is it?
Oh.
Hey, Mr. Murphy.
Uh-huh.
You got a problem with those. You looking right here? Came out of nowhere.
Why'd you get hit? Did you deserve it?
I didn't get hit actually. Randomly, just random blotch on my face.
He's not lying.
Actually not
Mr.
lying.
Murphy, he's really not.
That is kind of funny.
He just came in.
Are you going to be okay? You're not going to fall over?
I don't know, maybe I fucking did.
I disagree about that. I mean, how
Dumb.
all right, I understand drug addiction is really, really bad, but how bad do you have to be like, man, I'm going to inject myself with gasoline and whatever. And then all of a sudden you go to the doctor, my arms and my legs are falling off. What's wrong with me? Well, crack is bad for you.
Yeah.
Yes, sir.
So he has.
Awesome, I'll get it.
Is it getting worse? I stopped touching it, so.
It's got there.
Yeah.
Go ahead and do those as well, please.
No, the red.
All right. Yeah.
I stopped.
Oh, wow.
Red is